Hello students, today we are going to start lesson number 2, okay, that is the electrostatic potential and the capacitance. In lesson number 1, we have covered so many topics. You remember? It started from the conductor, insulator, the basic concept of the conductors, then also the Gauss's law, electric flux, electric dipole, electric field, like many. So in this lesson, electrostatic potential, so basically about the voltage of a material we are going to study, okay, electrostatic potential. Also the second part of the lesson, capacitance also there. So what is exactly the electrostatic potential is, we can define like this one. The electrostatic potential of a charged body represents the degree of electrification of the body. What quantity, how much electrification is happened to a body, that we can say or that we can understand using the term electrostatic potential. Okay, then the charge always flow from a body of higher potential to a body of lower potential. You remember like how water flow, water always flow from higher level to lower level. Temperature always flow from higher temperature to lower temperature. The similar way, the charges always flow from a body at a higher potential to another body at a lower potential. Okay. Then there are some situations where you need to answer 1 mark question, like define electrostatic potential. Even it is using the word potential, actually this is a type of work done. Okay. This is a type of work done, the work required to bring a charge from one point to another point. That depends on the starting and ending point, the term will change. Electrostatic potential is the potential difference is the. So we can define in this way, the electrostatic potential at any point in an electric field is equal to the, after that the important word exists, amount of work done per unit positive test charge. Okay, or we can say like in bringing the unit positive test charge. So you know that to move an object we required work done. In the case of charge also we required work done. So that work done is actually the electrostatic potential. Okay, that means it is for bringing the unit positive test charge from infinity to that point, we can say. Okay, so electrostatic potential is the work required to bring a unit positive test charge from infinity to a point where electrostatic field or electric field exists. So definitely there is a work done against the existing electric field. Okay, so definitely in the work done calculation you will see there is a negative symbol exists. What is the role of the negative symbol is, that says that the work is done against the existing electrostatic force. What is exactly electrostatic force? The force between two charges. Already there is an electric field, the reason is there was a charge. Then another one unit test charge is bringing, so the work is doing against the existing repulsive force. That is the reason the work done, when we do the calculation there will be a negative. Okay, that work done is actually known as the term electrostatic potential. So we can say like V is equal to W by Q, SI unit is volt. Now electrostatic potential difference, it is the amount of work done. The first one also amount of work done, but that case is bringing the charge from infinity to a point. And this is also the term work done. It is the amount of work done in moving a unit positive test charge. Then what is different in this topic compared to the previous topic? Previous topic, work required to bring the charge from infinity to a point. In this case, work required to move a unit positive test charge from one point to another point within the same electric field, we can say. Or we can say like this one, from one point to other point against electrostatic force. Okay, against electrostatic force without any acceleration. Now these two terms are clear for you. The first one is electrostatic potential, second one is electrostatic potential difference. In both case, work done exists. Then what is the difference? In case 1, work done is doing or work done required to bring the charge from infinity to a point. In this case, from one point to another point within the field, we can say. Okay, so how to do the work done is, you know that work done always force into displacement, right? So here the work done is equal to from A to B is equal to integral A to B F dot dr. Here F external mentioned, meaning is there is an external force, electric field or electric force produced by the electric field is the external force here into the displacement taken, that is dr. So minus right outside is equal to minus integral A to B F dot dr. Okay, F dot dr. Here that external force is the force due to electric field, we can say. Remember this equation we required. Next term is actually the 2 mark this one derivation. Rarely asked like a 3 mark derivation, because in 3 mark derivation the first part there will be like either first electrostatic potential or potential difference definition also will be asked. Now we can start this one. Suppose we have to calculate. Okay, we start this one. You write the title first, electrostatic potential due to a point charge. Suppose we have to calculate electrostatic potential at a point, okay, or at any point, we can say. So how to calculate? There will be some mathematical steps, there will be some integration symbol, but don't worry, if you are not good in integration, we are not going to do in detailed integration. Very basic identity we will use it, okay. So see the text what I am writing. Suppose we have to calculate electrostatic potential at any point P due to a single point charge plus Q at origin. Maybe you are not understanding now what I am going to say. When I draw the diagram, you will understand. You will understand it easily. So where OP distance is the R distance. So let me draw one diagram here. Assume there is a charge exists, okay, at the origin. This is the origin O, and now mark another one point after certain distance. So like this we can say, and continue marking, because we have to mark 2-3 points, like point A we want to mark, point B we want to mark, point P we want to mark, everything. So this is the point P, and the distance of the point P from the origin is small letter r, okay. And 2 more points consider on the same path. One point we can label A, other point we can label B. Then the distance between them, or distance from A to B, is dr, okay, dr. Now what we are going to do actually is, we make a prototype equation first, a small equation for small movement. Later the same equation we will be using for integration purpose, like a full movement. Full movement here is the case from infinity to that point, okay, full movement is from there. So where is exactly the point A right now is, it is at a distance, we can label like x now, okay, x we can mark. So the diagram you saw, what is the diagram showing? There is a origin, at the origin there is a plus Q charge placed, okay. Then there is a point P which is at a distance r from the origin. On the same line there are 2 more points A and B, and what we are going to say is, there is a work required to move a charge from the point A to the point B. That work done first we will calculate, that is the small work done. Later we will use that work done to start the movement from infinity to the point P, where P is at a distance r from the origin. So by definition, so before that I marked the direction of electric field also there, okay, positive charge, so directed away from the charge. By definition we can say like this one, electrostatic potential at P is, what is electrostatic potential definition? Amount of work done, right? That repeating again now, okay. So by definition, electrostatic potential at P is the amount of work done, okay, amount of work done in carrying a charge. You can specifically say about the charge now, okay, carrying a unit positive charge or unit positive test charge, you can say, okay, from the point infinity to the point what we are labeling in the diagram. Okay, from the point infinity to the point P. Got the point? So by definition what we can say, electrostatic potential is the work required or amount of work required to carry a charge from infinity to a point P. Okay. Now we are going to make that small equation for the movement from A to B. So at some intermediate point, you can see on the from infinity to point O, the origin, on the path, on the way, the points A and B exist. So at some intermediate point A on the path, okay. So at some intermediate point A on the path, where we label it now OA, that is the A point, OA distance is equal to X. OA distance is equal to X. All label we will introduce, what we are already marked, that we will write, including the writing. Okay. So we are going to write the first equation now. First equation we are going to write, okay. The electrostatic force on unit charge placed at the point A, we are going to write. How we will write? Using Coulomb's law we will write. So the electrostatic force on unit charge, that is unit charge meaning is the charge value is equal to 1 coulomb. Okay. So there is a 1 coulomb charge placed at the point A. Okay. So what type of force exists between the origin and the point A? Repulsive force exists. The reason is at the origin there is a charge already placed. Name of the charge is plus Q. At the point A there is a test charge. The value of that charge is plus 1 coulomb. So this is the one, plus Q. Okay. Now we write the Coulomb's law. Coulomb's law is the force between two charges, right? F is equal to 1 by 4 pi epsilon 0. The first charge here is plus Q, origin charge. Second charge here is the test charge, that is plus 1 coulomb. Divided by distance between them square. Because you know the equation, yeah, 1 by 4 pi epsilon 0, Q1, Q2 by R square. And direction is along OA direction. Remember, from origin to away, OA direction. Now we can skip that into 1 because it gives the same answer, right? So F is equal to 1 by 4 pi epsilon 0 Q divided by X square. This is the force. This is the external force. I said before, right, work done will be calculated by using force into displacement. That force is this force. The external force is this force. Put it in the box, okay. So F is equal to 1 by 4 pi epsilon 0 Q divided by R square. Now the real work start. Real work meaning is calculation of the work done starting now. That is work required to move the charge from the point A to the point B. We are going to calculate now. Okay, going to calculate. How we will calculate? Using the work done equation, force into displacement. So see that statement. Now small amount of work done in moving a unit positive charge from which point to which point we marked in the diagram, dr, that is A to B. Yeah. So a unit positive charge from A to B is, we can write, you know that what is exactly AB distance. We already there in the diagram. Distance between A to B is dr is. Look into diagram. Distance between A to B is dx. Okay, not dr we used, dx we used. Okay, for us no matter which variable we will handle with the subject knowledge. So the work done dw is equal to, we are calculating the small work done, that's why it is dw is equal to, actual equation for the work done is force into displacement. You saw in red color I marked within a box the force already I listed there. Force is equal to 1 by 4 pi epsilon 0 Q by R square. So force we are going to write that one, the small work done, okay. Displacement we will look into diagram and we will write. We already spoke about that one. Displacement happened from point A to the point B is dx. Yeah, dx. So dx we can say. So small work done is 1 by 4 pi epsilon 0 Q by X square dx. If you have the small work done, that is from specific point A to B, then you can go with the actual definition, right? What is the actual definition? The total work done to move or to bring the charge from starting point infinity to the end point, that is the point P, which is at a distance R. we are going to write. So in this type scenario we use integration. So integration is basically adding up, sum up. Okay. So the total work done in moving a unit charge from infinity to the point P is, what supposed to do is just apply the integration symbol apply. So total work done, integral dw is w because integral dx is x. So integral dw is w is equal to, now apply integration, integral from lower limit is infinity starting point and upper limit is small letter r. So infinity to r minus 1 by 4 pi epsilon 0 q by r square, instead of r square here is q by x square because the distance here is x square dx. What is the step of integration is always write the constant outside. How to identify the constant? Look into the letter coming after the small letter d, that will be a variable. Everything else will be constant. So here see after d small letter x is there. So x is the variable, do not touch, don't move outside the integration. So minus q, there is a minus, reason I told you the minus. Q by 4 pi epsilon 0 because these are the constant, 1 by s square dx. And w is equal to minus q by 4 pi epsilon 0 integral infinity to r. Now bring up this x square, bring up. So the sign, the exponent's power will change, right? So x bringing up, so x square become x raised to minus 2 dx. Okay. What is the role of the negative, or why we applied one negative? Because already there is a charge at the origin, positive charge, and when you try to move another one positive charge towards it, you want to work against their repulsive force. So negative sign indicates that work is done against the electrostatic repulsion between them. Okay. Negative sign indicates that work is done against or opposite to the electrostatic force between the charge at the origin and the unit positive charge moving towards that point or close to that point. Okay, that is the role of the negative. Now this is the time to use our skill, our knowledge to do the integration for integral x raised to minus 2 dx. Okay. So what we do is we are going to use one identity now. Which identity you know, yeah? Many identities you learned, like a plus b whole square is equal to a square plus b to ab plus b square. Then a plus b, a minus b whole square also you studied, a square minus 2ab plus b square. Then a plus b into a minus b is equal to a square minus b square. Many identity you studied. Just add this also to that account. So using the identity, one basic identity in the integration, this one, integral x raised to n dx is equal to x raised to n plus 1 by n plus 1. What is n here? The power. Look into the above equation. Actually we have a term like that one, x raised to minus 2 dx. N here is minus 2. So what we do? Integral x raised to minus 2 dx is equal to x raised to minus 2 plus 1 because n plus 1, right? Divided by minus 2 plus 1 because denominator is n plus 1. So n raised to minus 2 plus 1 is minus 1 divided by minus 1. That normal mathematics, okay. So what happened now? There is a negative formed in the denominator. You notice that you write as the common denominator. I mean the common for numerator and denominator. Then bring back that x raised to minus 1. So you know that when bringing from numerator to denominator or denominator to numerator, existing power sign will change. So here it is minus 1 by x raised to plus 1. Usually we will not write 1 raised to x raised to plus 1, right? Will not write. No need to write again. I mean power 1 no need to maintain. So work done is equal to minus q by 4 pi epsilon 0 inside the bracket, because integration over, integration symbol taken out, minus 1 by x. Write the same limit, lower limit infinity, upper limit r. Now is equal to, you can see 2 minus, the starting point there is a minus, inside bracket there is a minus, so become plus. Then q by 4 pi epsilon 0. This is the way of applying the integration limit, okay. A long bracket you put first, put a negative between them in the middle. Then replace the variable with the upper limit first. So 1 divided by x place, replace with r. Then minus 1 by x place, again replace, this time replace with the lower limit 1 by infinity. You know the term 1 by infinity is 0, right? You learned before. Everyone know that one. So 1 by infinity is 0. So what left now? Work done is equal to q by, again no need to write plus q because that is by default read as plus q only. Q divided by 4 pi epsilon 0 1 by r. You remember electric field equation? 1 by 4 pi epsilon 0 q by r square. This one is 1 by 4 pi epsilon 0 q by r. Yeah, this is the work done. That is, this is the electrostatic potential due to a point charge. So this topic asked many times. Okay, but 2 mark, most of the time 2 marks only. Rarely, along with other definition question, 3 mark came. Okay. So V is equal to, why V? Because the definition says work done is equal to the potential. So work done W is equal to, V is equal to 1 by 4 pi epsilon 0 q divided by r. Put it in a box now. V is equal to 1 by 4 pi epsilon 0 q divided by r. Okay. How is this derivation? Simple, right? I don't think this is complicated. You can skip some steps after you understood well, okay? Because I used maximum steps to make understand the students, those who are performing below average, okay? But you can skip the steps, no problem. Okay, so what we did today? This we did. Just have a look. One small plenary. Electrostatic potential due to a point charge, derivation over. Remember, diagram is important. Based on the diagram variable, we make our derivation. If there is a mistake in the variable, definitely the derivation will go in other angle. Yeah, other direction. Okay, that's all. That is for today. This video is the first video from lesson 2. Please wait for the next topic. It will be there soon. Thank you. Have a nice day. Bye bye.